In the last video, we saw the two situations where we'll have a horizontal asymptote. Now we're going to look at slant asymptotes. So this is our third situation. If the degree of the numerator, p, is 1 more than the degree of the denominator, so the degree of q plus 1, then we can use the division algorithm to write r of x equals ax plus b plus some remainder polynomial over q of x, and y equals ax plus b is the slant asymptote. A slant asymptote is an asymptote that is neither vertical nor horizontal. It ends up being diagonal or slanted. Let's take a look at an example of a function that has a slant asymptote. So let's consider f of x equals x squared minus 4x minus 5 over x minus 3. In this case, the degree of the numerator is 1 more than the degree of the denominator, so we know we're going to have a slant asymptote. To figure out what the equation for it is, we need to actually perform the division. Now, in this case, we can choose to use long division or synthetic division because the denominator is x minus a number. I'll use synthetic division here to save time, but remember, if the denominator is ever a second degree or more polynomial, we're going to have to use long division. So we've got 1, -4, and -5. The value of c is 3. So we bring down the 1, we multiply, we add, then we multiply, and we add. And this tells us that our rational function is equivalent to 1x minus 1 plus -8 over x minus 3. Remember that this -8 is the remainder. Now, what this tells us is that the slant asymptote has equation y equals x minus 1. So this is our slant asymptote. And this means that as x gets larger and larger, either in the positive direction or in the negative direction, our graph is getting closer and closer to the diagonal line y equals x minus 1. The reason for this is if we look at this last term here, as x gets bigger and bigger, the denominator gets larger and larger, and so this term gets smaller and smaller. It gets closer and closer to 0, which means that our graph is getting closer and closer to the graph of y equals x minus 1. And here we actually have a graph of our rational function, f of x equals x squared minus 4x minus 5 over x minus 3. We can see I have graphed the slant asymptote y equals x minus 1 as a dashed line, and we can see that the curve is getting closer and closer to it as we move to the right and as we move to the left. So this is an example of a rational function whose end behavior has a slant asymptote. I've also graphed the vertical asymptote that we get at x equals 3, because when x equals 3, the denominator is equal to 0 and the function's undefined. So here's an example of a graph that has a slant asymptote as well as a vertical asymptote. We are going to focus more on looking at the end behavior this lesson than graphing. We're actually going to save graphing for next lesson just because each graphing problem takes quite a bit of time. And right now, I prefer on just focusing on learning about the asymptotes before we go through the trouble of sketching a graph with vertical asymptotes, possibly horizontal or slant asymptotes, intercepts, and all sorts of other things. So right now, it's just important to be able to identify if there's a horizontal or slant asymptote, and in the next video, we'll look at situations where the end behavior doesn't have an asymptote at all.